Hi everyone. In this section, we're going to be taking a look at some generic classes and how we can use some types of type bounds with those generic classes as well. So again, a generic class is where we can have one or more type parameters, and these parameters are actually used immediately after the name of the class. And again, after we go ahead and we define a class name where we provide param 1 and 2 and so forth, we are going to create a definition in which these parameters are used. Now, type parameters cannot be instantiated with primitive types. Again, this is similar to what we saw earlier with our toString method and how how we weren't able to use int and boolean inside of our generic printing out variable. So this is just something to remember. And another thing here, before we take a look at entry and test entry, is this concept of type bounds. So sometimes the type parameters of a generic class or method need to fulfill certain requirements. And if this is the case, we can specify a type bound. So if we go ahead and we specify a type bound, it will require that the type extends certain classes or implements certain interfaces. So again, if you want to ensure that an array list that you're using of a type is treated as a number, you can require that it extends a number class. You can also have multiple bounds, and the way that we can connect these multiple bounds is by using the AND operator or the ampersand operator. Now, again, we're going to take a look at this in a generic demo.java too, but first of all, let's take a look at our entry and testentry.java file. So we can see here that inside of my public class of entry, I have these two type parameters called k and v, and I have my definition where they're used right away. Now, what we do after we go ahead and we create k and v, which is similar to our regular layout of a class and its constructor, is to create a constructor object and then reference these two types that are there. Now this will go ahead and say get the key of an item and get the value of an item. And the reason why we want to use it this way is, for instance, maybe we want to make a class that is generic and we don't want it to require a specific type of object to be put in. So here we'll see we'll have a key and a value. And what if we want to go ahead and, for instance, create one of these entry items? We could take a look at the testentry.java file. And you'll see here that I'm able to create an entry object that has a string and an integer. And it takes in these two parameters of John and 50. And then we see down here that we have a string and a double. And it takes in these two parameters of string and a double again. So I can go ahead and create this, and these objects will go ahead and operate just like we normally make them. And we can go ahead and make another object if we want, and maybe we could say integer string, and this will be entry is equal to new entry. And what the new entry is going to be the first one is going to be an integer of 50, and the second one will be another one of maybe rows. And we'll see here, because this is a generic object, we're going to be able to use the exact same methods and parameters that we used before to go ahead and get these entries working. So I'm going to call this one the third entry. And we can see now that in my first entry, I get my get key and get value, provided these parameters up here. And then in the other ones, I get the keys and the values provided down here. So again, the way that you create a generic class like so is by providing these two parameters. They don't need to be k and v. These could be anything that you'd like. You can call it a and b. But if they're called a and b, everywhere that you reference them, such as down here, a, b, need to be also of the same type. So again, this is one way that you could go ahead and make sure that you get the correct types here. And this a and b is a placeholder, and it's just a placeholder for any type of object that is provided to this entry class. So again, usually we want to be pretty specific about the types that we're making in object-oriented programming, but in scenarios where it might be a bit beneficial to have it be more generic, this is the way that you can make that generic class. The second part of our code I wanted to take a look at here is these type bounds, and we can take a look at it in the generic demo.java file. And we can see here there's quite a bit going on here. And what our type is going to be looking at is that we could have a few bounds which go ahead and fulfill certain requirements of our type. So this might look a little complicated, but again, if we try to run our generic demo here, we'll see here that we create an array list of a type of integer, and then we iterate through it by adding items into it randomly. We go ahead and we print out the random values by going through another for loop, and then we just go ahead and finish it up here. What we're going to try to do here is a try and catch where we find a max of an array. Otherwise, we have an error that's printed out, and that's about it for our items here. Now, this find max parameter, we can see here that it extends the comparable interface of t. So now we are providing the t. Again, this looks a little complicated, but this is just like what we did over here. And why are we needing to do this extends comparable interface? But you'll notice that if I deleted that comparable interface, I get this error down here that says val.compared to. So I need to go ahead and extend this comparable interface of type t. This public static t is going to take in a t of type, and this find max is going to take in an array list of any type that's generic called elements. You can see that there's a throw exception right here. You don't need to worry too much about throw's exception. What this does is that if you have a throw clause inside of your code, you have to put this little reference up here. This is just a try and catch kind of as well. We can see that this is the if statement that goes ahead and checks if the size is 0. What we really want to look at is that we have this type of max, t is a generic type, is equal to the first element of this elements array that were brought in. We also have a type of val, and what we do is we go through the entire array, iterate through it. We're going to set the val equal to the current index of our array list, the value that's there, and then if it's greater than the max, we set that to the max item. We are then going to return max down here, and we can see here that there's a few different generics that we could use. So this generic class of find max is where we can see that we can use this array list. What if I try to do something where I try to find a max of a string? See here. I'm going to very quickly create a new array list of type string, rs. This could be equal to a new array list like so. And what I'm going to try to do here is I'm just going to add in a few strings into my array list here. The similar ones that we've used so far. Something like this. And after I added these items in here, I'm going to try to find the max of my array list. So I'm going to go ahead and do a system.out println string array. And what am I going to print out here? A find max of rs. Now we'll notice here, oops, let me make this capital one. We'll notice here when I try to do a find max, we're going to need to, let me also add in a try and a catch right here, just in case something happens. This is an automated one, essentially, very similar to our try and catch down here. The reason that this is added for us is because we have this throws exception, so we need to make sure that this exception is caught for us. So if I run this, we'll now see here that the string array gets the testing as the max value. And how am I comparing elements of strings inside of my array list? Well, the way that I'm comparing them is by using this concept right here of extends comparable of t. So again, everyone, this is a little convoluted, but essentially the main thing I want everyone to focus on is that there's these t's that are of a generic type. And the more that you use these t's, I can use arrays of different types to work with that. So if I change this from testing to a, we'll notice I now get the largest value to be the A or rows that's above it there. And if I change this one to Beatrice, like so, we'll now see that rows is the large one because they are comparing the first item here. Let me try to set this one to zebra. And now we can see that the zebra is the max one. So again, this is just trying to try and catch with these generic classes and these interfaces. And now, why don't we try to take a look at this method that's here? Write a method getIsum that returns an int consisting of the sum of all elements in an array list t, where t extends number. What this does for us is we say public static t, and if we want to extend something that isn't the comparable class, again, this is called the type bounds. This is the concept that we've been looking at over here. We're going to say this extends the number class, and it's going to return an integer where I get the sum of every element in an array. So my int sum is going to start at 0. I'm going to iterate through every element inside of my array, sum them up, and then return them. And the most complicated part of this is really, this is something that we've seen before like so. We've seen method declarations like this before, but again, if we are trying to extend of a t type right here, we need to make sure that the t is provided for us inside of the parameter list. Now, I want to make sure, if you could see here, I get the .int value the method int value is undefined for type T. So only numbers inside of our Java classes are able to have this int value method. So I need to extend a number class in order to get access to it. And again, extend is kind of like the concept of inheritance that we looked at a few weeks ago. If I try to run this one, I'm going to go ahead and see that the sum of the value of the array elements is 29. If I run it again, we'll see it gets up to 36 because it adds up all these guys together. And then my largest array item is still 0. And again, it looks like my find max is working not just for an array list of integers, but also for an array list of strings. And again, this does not work with primitive types inside of Java, so we're going to need to rely on strings, integers, or doubles as well to work with it.